Welcome to The Explainer. So today we're tackling something pretty wild in the world of artificial intelligence. We're going to talk about a new AI that doesn't just crunch numbers, it actually learns when it needs to stop, take a breath, and think. All right, let's start with a super simple question, because it gets to the heart of a huge problem in AI. How much brain power does it take you to figure out 2 plus 2? Pretty much 0, right? Okay, now what about a crazy complex physics problem? See, you automatically adjust how hard you think. But what about AI? And that's where we hit the wall. You and I were adaptive. We use just enough mental energy to get the job done. But most AI, they're rigid. They have one speed, they throw the exact same amount of brute force at every single problem, no matter if it's super easy or mind-bendingly hard. So that leads us right to the main problem here, what the paper calls AI's one-track mind. It's all about this issue of fixed computation. You know, the best way to think about it is like this. Imagine a chef who spends exactly 1 hour making a piece of toast, and then also spends exactly 1 hour on a 5-course gourmet meal. It's totally inefficient, right? It just doesn't make any sense. And that's what standard AI models do. They're stuck with this fixed budget that looks at how big the input is, not how complex the actual problem is. So the process is always exactly the same. Step 1, get the problem. Step 2, apply the same old fixed amount of thinking. Step 3, spit out an answer. It doesn't matter if it's something simple like spotting a cat in a picture or something that needs real reasoning. The effort is always identical. It's so wasteful. Okay, so this isn't a new problem. Researchers have been trying to crack this for a while, which brings us to the first attempt to build a thinking machine. A really brilliant idea, but as you'll see, it had some serious flaws. So back in 2016, this idea came along that was a real game changer. It was called adaptive computation time, or ACT. And for the very first time, it was an attempt to let a neural network learn for itself how long it should think or ponder about a problem. But there's always a but, right? ACT had some major issues. The paper points out that it was super unstable when you tried to train it. And it was ridiculously sensitive to this one setting. Think of it like a control knob that was almost impossible to get just right. To top it all off, there was a fundamental math problem with it, which meant it wasn't even learning from its mistakes properly. So yeah, it was clear a much better solution was needed. And that brings us to the big breakthrough we're here to talk about, PonderNet. This is where things get really interesting. PonderNet flips the whole script. Instead of just trying to force the AI to be more efficient, it does something way smarter. It learns to calculate the probability that it's done enough thinking. At every single step, it basically asks itself, okay, am I confident enough to give an answer now? It learns to make that call on its own. And that one single shift, it's the core innovation here. It's a huge deal. The authors put it perfectly. We achieved this by reformulating the halting policy as a probabilistic model. This has consequences in all aspects of the model. In other words, changing that one thing, it changed everything. So now the whole process looks completely different. That rigid one-way street is gone. Now it's more like a highway with a bunch of off-ramps. PonderNet does a bit of work, then asks, should I exit here? If the answer is no, it keeps going to the next off-ramp and asks again. It learns to take the first exit for easy problems, but to stay on the highway and keep driving for the really tough ones. All right, the theory sounds great, but how did it actually do in a real test? Let's look at the evidence. And the results are, well, they're pretty staggering. They gave both models a logic puzzle, but then they threw them a curveball, a way harder version that neither had ever seen before. This is the ultimate test, right? PonderNet nailed it. Almost perfect accuracy. And the old model, ACT, it completely fell apart. It was basically just guessing. So you gotta ask, how did it pull that off? Simple, it adapted. PonderNet actually realized, whoa, this problem is harder, and it automatically doubled its thinking time to solve it. It changed its own strategy on the fly to match the challenge. That is so cool. And it's not just about getting the right answer, it's about efficiency. This is wild. On a really complex Q&A test, PonderNet got the same top-of-the-line results as the older ACT model, but, and this is the kicker, it did it using over 80% less computation. Just think about that. Same results for a fraction of the effort. It's smarter and more efficient. Okay, so this is obviously a huge deal for researchers. But what about the rest of us? What does this mean for the real world? Why should you care that an AI can ponder? Well, the impact is actually massive. This isn't just about speed, it's about efficiency, which means lower energy bills and less cost to run these things. It's about accessibility. Imagine having truly powerful AI running right on your phone, not just on some giant server in the cloud. And maybe most importantly, it's about making AI more reliable, more robust when it has to deal with the messy, unpredictable real world. And that really brings us to the final big idea here. For so long, the go-to solution for better AI was just make it bigger, throw more data at it. But PonderNet, it points to a totally different path. It's not about building bigger AI, it's about building smarter AI. An AI that knows how to manage its own resources. It's a shift from teaching AI what to think to teaching it how to think. And that, well, that could change everything.